Hey everyone, this is Miss Krepstad, and this is a video for when I am gone. Um, Hopefully I was able to figure out how to make this into an Edpuzzle. If so, you need to watch the full video, you need to answer all of the questions that pop up throughout the video, and then you need to make sure you press submit at the end to get full credit for watching the whole video. If this is not an Edpuzzle, in other words, if questions do not pop up as you're answering, then I wasn't able to figure out the technology and you can just watch the whole video as usual. But I can see whether you watch this or not. The first thing we're going to do is just review yesterday. So I want you to figure out, and you can do this on the scratch paper at the back of your packet, is I want you to tell me, is 1,5 a solution to this system of equations? That 1,5 is not a solution to this system. You could have graphed these to see that, but since you didn't have graph paper, what you could have done is just plugged in 1 for x and 5 for y. When you do that in the first equation, it does work. You end up with 5 equals 5, so that's a solution to that line. However, when you plug that point into the second equation, it does not work. You end up with 5 equals 2, which means it is not a solution to the system. Here's another review of yesterday. Here I'm giving you a system as well as a graph already. I would like for you to tell me what is the solution to this system of equations. I've had the point -3, -1. Again, be careful when you are writing points. You always have to write your x value first and your y value second. So we had to go left 3 and down 1 to get there. All right, let's get into what we're going to be talking about today, which is review of some other things we've covered. It's solving linear equations. In topic 4, we will be getting into a lot of algebra and manipulating equations and getting variables by themselves. So it's really good to have some review to make sure we know what we are doing. On page 4 in your notes, and we're going to start with just some really simple examples, and we've done stuff similar to this already. Example 1 in this box, which said you have 1x on one side of the equal sign. This is about as simple of an equation as you can solve. We have x plus 4 equals 3. Now, for those of you who know the answer already, I do want you to move into using algebra in order to solve these equations versus trying to guess and check. So we are going to undo the operation. I like to use train tracks, but we're going to undo the plus 4, which means we are getting x all by itself. So we are left with just x on that left-hand side, and then we have to do 3 minus 4, which gives us -1. So we have that solution there. Here's another example. If I have -3x equals 12. Again, my goal is to get x by itself. This time I have -3 times x. The opposite of timesing is dividing. So I need to divide both sides by -3, which leaves me with x equals -4. Again, this might seem like something you already know, and that's great. They are going to get more difficult, but the big space that I left up here is really to enforce the fact that anytime you're solving, you are undoing PEMDAS. Oops. Okay, what I mean by undoing PEMDAS is we are going to work our way backwards. So if there's anything we could add or subtract to get rid of, we'll do that first. Then we'll figure out multiplication and division if we can, and then we'll do exponents, and then we'll worry about the parentheses. That is a little bit difficult sometimes in some problems. We're going to do 2 examples over here. Okay, here again, this one's more straightforward because I'm going to do the opposite of PEMDAS. So I'm going to add or subtract first. So instead of minusing 5, I'm going to add 5 to undo it, which leaves me with 2x equals 16. And then I'm going to do multiplication or division. And here I'm multiplying. So I'm going to divide both sides by 2, which leaves me with x equals 8. Now, of course, just like what we did yesterday, you can definitely check your answer if you would like by plugging in that 8 to see if you end up with a true statement. Oopsies. It's supposed to say 5. So that works. All right, the next one's going to be a little bit trickier. we're going to have x plus 1 divided by 2 equals negative 6. Now, some here might say, oh, I have to add or subtract first, so I'm going to subtract the 1. Well, we can't subtract the 1 because the 1 is currently in like a grouping symbol. It's not shown here, but whenever you have division or a fraction, the top or the numerator stays together and the bottom stays together. So we can't subtract the 1 because it's stuck. So we have to kind of jump over that step, and instead we're going to do the opposite of dividing by 2, which is to multiply by 2. That leaves me with x plus 1. Oh, I don't need those parentheses. I put those parentheses in, so they're not necessary. X plus 1 equals negative 12, and now that 1 has been released, so I can subtract. Once again, we can check if we would like to make sure we got this correct, where we plug in negative 13 plus 1 divided by 2 and see if that ends up giving us negative 6. That gives us negative 12 divided by 2, which is negative 6 equals negative 6. On the next slide, I'm going to ask you to talk or think about how you would solve the following problems. All right, I hope that went well for you. And here we're just going to continue on in the adventure of learning how to solve equations. It's going to get a little bit more difficult from here. So for example, we will have something that looks like this. 3x plus 8 minus x plus 5 equals 21. And what you'll notice is that now we have multiple x's on one side of the equation. So as we talk through the process of doing that, we will solve this problem. The first thing we're going to want to do is we're going to want to do what we call cleaning up. Okay, cleaning up involves us combining things together that we can on a side. So we don't need it to be this complicated. We can combine together like terms. What I mean by like terms are terms that have the exact same variable. So we're going to clean up like terms. Okay, so what that means is like I can do 3x minus x. That is allowed because they are both x's. I can also combine together this plus 8 and the plus 5 because those are like terms. This 21 on this other side is just by itself, so there's nothing really to do over there. Now, when I'm combining like terms, I'm going to do the operation that's in front of it. So I have 3x minus 1x, which leaves me with 2x. And then I have a positive 8 plus 5, which gives me a positive 13. Now I'm back to doing the opposite operations that I did before. So the second step is going to be undo PEMDAS to solve for x. Okay, so that would involve subtracting or adding if I can do that first. So that leaves me with 2x equals 8. And then because I'm multiplying, I'm going to divide both sides by 2, which leaves me with x equals 4. All right, let's put another example on the other side with something a little bit trickier. This time I'm going to have 3x minus 2 equals 7x plus 10. Here you'll notice that we have x's and numbers on both sides of the equation. This works a little bit differently. I'm not just combining them together. I have to move the x's from one side to the other and the numbers to the other side. So this involves, because we're crossing over that equal sign, I have to do opposite operations. There are several different methods you can use for this, but typically what we do first is we undo x on one side of the equal sign to get both x's on one side. So what that looks like is I'm going to do the opposite of an x. So I have a positive 3x, so I'm going to minus 3x from both sides. You could minus either one, it would not matter. What that leaves me with is negative 2, and then 7x minus 3x is 4x, and then I have that plus 10. Then I'm going to undo PEMDAS to solve for x. I just realized this might be kind of confusing notation. I'm writing the slashes in between so that you know you could add or subtract, okay? You don't always subtract before you add. You don't always add before, anyways. So you can always kind of mix those around because they go together. So now the x's are on the other side, so I'm going to minus the 10 because my goal is to get the x alone. So x has a lot of stuff with it right now, so that leaves me with negative 12 over here and 4x on the other side. I have multiplication between the 4 and the x, so I'm going to do division. And that's going to finish up this problem. As a reminder, it does not matter what side your x is on for the equal sign. On the next slide, you're going to solve a few more problems, and then you're going to get going to your personal practice. All right, that's the notes for today in the practice. So now you can work on either the 40A practice worksheet, which you can get from the substitute, the 40A practice in your note packet, which starts, I believe, on page 14, or the 40A Savas or Easy Bridge assignment, which can be found on your lunch pad.